Hello viewers, welcome to the channel. Myself A. Satyanarayana, Assistant Professor of Mathematics, SRR Gout Arts and Science College, Karimnagar, Telangana, India. In previous class, we had discussed the spheres which are touching externally or internally. Today we are going to solve some problems on touching spheres, finding the point of contact, and second concept is the angle between two spheres. Yesterday we have seen that if two spheres touches, there will be two cases. One is touch externally and the second one is touch internally. So here is the problem related to spheres touch externally. This is the first sphere. This is the second one. And I am drawing in some better way. No. Yeah, assume that spheres are touching at some point P. It is the center of first sphere. This is the center of second sphere. C2 and C1. Now I am joining the point C1, C2 and also P. Then here P divides C1 C2 in the ratio of radius. C1 C2 P divides C1 C2 in the ratio R1 is to R2. We can find the coordinates of P using section formula, that is mx2 plus nx1 plus m plus n, my2 plus ny1 by m plus n, mz2 plus mz1 by m plus n. This is the formula used to find the point of contact of the two spheres. Here m is to n is equal to, we take R1 or R1 is to R2 and x1 y1 z1 x1 y1 Z1 is the center of first sphere, X2, Y2, Z2 is the center of second sphere. Here we need two centers and also radius of the two spheres. Now we going to the problem. So problem number 1, practical question 6. Prove that the spheres x square plus y square plus z square equal to 25 and x square plus y square plus z square minus 24x minus 40y minus 18z plus 225 equal to 0. These are two spheres are given, and also said that they touch externally. Show that or prove that they touch externally. This is the sub question A, and also find the point of contact P. Point of contact P. This is sub question A and B. We start small a. Yeah, these are the two spheres. X square plus y square plus z square equal to 25 or minus 25 equal to 0, and x square plus y square plus z square minus 24x minus 40y minus 18z plus 225 equal to 0 is the equation 2. So writing the centers, here origin is the center to the first sphere. Why? Because here xyz coordinates, xyz terms are 0, therefore uv are 0. For second sphere, using minus u minus v minus w, here 2u equal to minus 24, u equal to 12, so minus u equal to plus 12. Similarly, minus v equal to 20, minus w equal to 9. So these are two centers. We can treat these as x1, y1, z1. This is x2, y2 and z2. And also radius. Here radius of first sphere is 25. Why? Because we can use formula, or directly we can say if center is origin, the square root of constant will be the radius, or we can use the formula for radius, u square plus v square minus d. Here u is 0, v is 0, w square also 0. Here d is minus 25 minus d is plus 25 equal to square root of 25, that is 5. Similarly, we can find the radius of second sphere, that is minus u square 12 square or minus 12 square, v square 20 square, w square 9 square minus d, that is 225. Here is 12 square 144, 20 square 400, 9 square 81 minus 225. So simplifying these terms, we get 400, under root 400, that is square root of 400 is 20. And also we find C1, C2. In this problem, first we prove that they touch externally. Touch externally, that is the first point. The second one is find point of contact P. So here we are in the problem in the sub question A. So that's why the touch externally. For this we need we have to check the distance between perpendicular distance C1 C2 equal to, it should be equal to R1 plus R2. If they touch externally, C1 C2 equal to R1 plus R2. We have to check the equation. For that we have to find the distance between two centers C1 C2. So that is the C1 C2 using the distance between 2 points formula, x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square under root. Here x1 y1 z1 we are substituting this 12 minus 0, 20 minus 0, 9 minus 0 whole square. We get 12 square, 14 square plus 81. The sum of these terms 625, that is equal to 25. So similarly we find R1 plus R2. Here is R1 is 5, R1 is 5 and R2 is 20. R2 is 20, so total 25. Therefore R1 plus R2 is equal to R1 plus R2 equal to C1 C2 or C1 C2 equal to R1 plus R2. Therefore the equality is satisfied. Therefore we can write the given spheres touches externally. So here answer question, answer for sub question B. Here we find point of contact PB, the point of contact P divides C1 C2 internally, I'm sorry, yes, internally in the ratio R1 is to R2. Therefore R1 is 5, R2 is 20. Therefore 5, I am just simplifying this ratio, 5 4 ja. For 1 is to 4, we can take 1 is to 4 in a simple way. So using the formula here M1 M2 I have written in terms of Mn, in terms of Mn, no problem at all. So here it is the M1, this is M2, M1 x2 plus M2 x1 by M1 plus M2, M1 y2 plus M2 y1 by M1 plus M2, My2 plus M2 z1, M1 z2 plus M2 z1 by M1 plus M2. Substituting these values x1 y1 z1 and M1 M2, here are x1 y1 z1, the centers of two spheres. Substituting these values we get 1 into 12 plus 4 into 0, 1 into 20 plus 4 into 0, 1 into 9 plus 4 into 0, M1 plus M2 1 plus 4, 1 plus 4, 1 plus 4. Here is the 12, 20, 9. Therefore 12 by 5, 20 by 5 and 9 by 5. This is the coordinates of the point of contact. Coming to next problem, problem number 2. Show that the spheres x square plus y square plus z square equal to 64, x square plus y square plus z square minus 12x plus 4y minus 6z plus 48 equal to 0. Touch internally, touch internally and find point of contact. Find point of contact. Here also two questions. the question A and question B. If two spheres touch not get exactly sphere shape, yeah, it is the sphere. I draw one more sphere, yeah, exactly, two spheres. This is the point of contact, this is the center of the first sphere, the center of the second sphere. You can join these centers. C2, here it is C1, this is the point of contact P, and observe that P lies on the extension of C1 C2, extension of C2 C1. Here it is C2 C1, the extension, this part is called extension. P lies on the extension of C2 C1. In this case we say that P divides C1 C2 externally. To find the coordinates of P, we use the previous formula, but instead of plus we take minus. So here is the formula, m1 x2 minus, we are taking minus. Okay, we use the formula. Okay, let us go to spheres. The given spheres are x square plus y square plus z square minus 64 equal to 0. This is the solution for first question. And x square plus y square plus z square minus 12x plus 4y minus 6z plus 48 equal to 0. These are the two spheres, and the origin is the center to the first sphere, and center to the second sphere is 12, half of 12 6, therefore 2 and 6 3. Change the symbols also. So this is the sphere, center of the second sphere. So R1 equal to the square root of 64, or we can use under root u square plus v square plus w square minus d formula for the first sphere. For second sphere, radius R2 is equal to 6 square minus 2 square plus 3 square minus d, here d is 48, minus 48, under root 36 minus 2 square 9, 3 square 9 minus 48, here 40 plus 9 49, here positives are 49 minus 48, that is square root of 1, that is equal to 1. So we have find the radius of the spheres and also centers. Now we are going to find the distance between two centers C1 C2. We are using the distance between 2 points formula, under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, under root here x1 y1 z1 x2 y2 z2 are the centers. Here it is x1 y1 z1 x2 y2 and z2. So using the formula 6 minus 0 whole square plus minus 2 minus 0 whole square, 3 minus 0 whole square. So 6 square 36, minus 2 square 4, 3 square is 9, so 49, that is 7. So C1 C2 is 7, and R1, now we find R1 plus R2. R1 is 1, here it is 1, R2 is 8. So 1 plus 8, R1 plus R2 equal to 9. Similarly, C1 C2 equal to 7. Therefore, R1 R2 not equal to C1 C2. We have to confirm this first. So now we go to, after satisfying this, now we go to R1 minus R2. So modulus of R1 minus R2 equal to 8 minus 1, modulus 7 equal to 7. Therefore, observe C1 C2 equal to R1 mod R1 minus R2. If C1 C2 is equal to R1 plus R2, then it comes the previous case. So otherwise we try to find whether R1 minus R2 equal to C1 C2 or not. First we have to confirm C1 C2 is not equal to R1 plus R2. Here two spheres are touching externally. So next B. P be the point of contact. P divides C1 C2 externally, not internally. Externally. The ratio R1 is to R2, that is 8:1. So for external division, we use the formula m1x2 minus m2x1 by m1 minus m2, m1y2 minus m2y1 by m1 minus m2, m1y2 minus m2, m1z2 minus m2z1 by m1 minus m2. This is similar to previous formula except the minus. In previous formula, there is a minus between the terms. Okay, we substitute x1 y1 z1 and x2 y2 z2 values over here. These values are here. So substitute these values. 8 into 6, 1 into 0, here 8 into minus 2, minus 1 into 0, 8 into 3, minus 1 into 0, here denominators are 8 minus 1, 8 minus 1, 8 minus 1 equal to 7. So 8 into 6, 48, this is 0. Similarly, 8 into minus 2, here it is minus 16, and this is the 24, here minus 16. So but 8 by 7 minus 16 by 7, 24 by 7. This is the point of contact of the given two spheres. Okay. Here is the one more problem. If the tangent plane to the sphere, the tangent plane to the sphere x square plus y square plus z square equal to r square in the simplest form, taken in simplest form. The tangent plane makes intercepts ABC on x, y, z and r coordinate axis. Show that 1 by a square plus 1 by b square plus 1 by c square equal to r square. We have to show this equation. Here question is one sphere is given and tangent plane is given. The tangent plane not only touch the sphere and also makes intercepts on coordinate axis. So what are the intercepts? If we take two axes for convenience, we are taking x and y axis. The plane, tangent plane touches x axis A to A and y axis A to B. Similarly, we take z axis at some C. So in this case, we say that the plane making intercepts ABC, we can say that distances also. This is equal to B, this is equal to A, this is equal to some C. The distance from O to the point of contact, sorry, the point of intercept. Okay. So in this problem, we take the tangent plane in general form. So here is the tangent plane. There should be a point of contact. Let the point of contact P. So this is the sphere. The plane touching at some point P. Here it is the sphere. This is the plane. Then P lies on the sphere and also on the plane. So here PB the x1, y1, z1. When a point of contact is known, we can write the equation of tangent plane using the formula. So the formula we discussed in previous classes, that is x1 plus y1 plus z1 plus ux plus ux1 vy plus vy1 vy1 z wz plus wz1 plus d equal to 0. This is the formula for tangent plane. Tangent plane. So here u, v, w are 0, only constant term only, and x, y, z terms are there. Therefore, using the formula u, v, w are 0, taking u, v, w are 0, writing the tangent plane x1 plus y1 plus z1. Here d is minus r square equal to 0. This is the equation of tangent plane at P to the given sphere 1. So now we go to the intercept concept. Here I am using the concept of intercept. We find intercepts on xyz axis or coordinate axis using the equation of tangent plane, equation 2. First we find intercept on x-axis called x-intercept of the plane tangent plane 2. Generally we find intercepts by substituting some x00, substitute the point x00 to find intercept on x-axis. Similarly, to find intercepts on y-axis, we substitute y00. Similarly, intercept on z-axis, we substitute z00 and find the x, y, z values. First of all, we find the x-intercept. Substitute x00 in the equation 2, we get x1, we substitute in place of x1, y1, z1. We substitute in place of x, y, z. Here x1, y1, z1s are constant. We don't substitute in place of constants. We substitute in place of x, y, z. X is x, y is 0 and z is also 0. So we get here x1 0 plus 0 minus r square implies x1 equal to r square plus x equal to r square by x1. So here x is the intercept. X is the intercept on x-axis. If we find the value of x, then the value will be equal to intercept on the x-axis. So here the intercept on x-axis equal to OA. Here OA is denoted by x. Therefore, here it is nothing but a, x is nothing but a. Therefore, a equal to r square by x1. Therefore, x1 square equal to x1 equal to r square by a. Here I want to find x1, y1, z1 values. After finding the x1, y1, z1 values, I substitute x1, y1, z1, that is point P, on the equation of sphere. Why? Because P lies on the sphere also. Similarly, y-intercepts of 2 is y1 equal to r square. Y is nothing but y-intercept on y-axis. Here it is in the problem, it is equal to b. This is nothing but b. B equal to r square by y1. Therefore, y1 equal to r square by b. Similarly, we can find z1 is equal to r square by c. So now I am going to write the point P. The point P in terms of r square by c. So this is equal to r square by c and r square by a. This is r square by b and r square by c. x1, y1, z1 values. So since P lies on the sphere, therefore I substitute the coordinates of P in the equation of sphere. What is the equation? Here is the equation 2. Equation 1. X square plus y square plus z square equal to r square. Substitute the coordinates of a new coordinates of P, new values of P. r square by r square by a whole square, x square plus y square plus z square equal to r square. What is the equation of sphere? Equal to r square. Substitute these values, we get r square, taking r power 4 common. So r power 4 into 1 by a square 1 by b square plus 1 by square r square cancel. Here we have r square equal to shifting to right side 1 by r square. So 1 by a square plus 1 by b square 1 by c square equal to 1 by r square, which is the required relation. Okay, here it is the one more important concept, angle of intersection of two spheres. Okay, if two spheres may not touch either externally or internally, there will be another case, they intersect in a circle. Actually this is a circle. In that case we find the angle between two spheres, just like if two lines intersects, there may be an angle generated. Similarly, two planes are intersected at some along with a line, not at the point, along with the line. Two lines intersects generally at a single point, some q. Then two planes intersects in a line, not at a single point. And if two spheres intersects, either a may touch or intersect at a point or intersects along the circle. If they intersect at a point, then we will say that those are touching circles, touching spheres. If they intersect along the circle, we say that these are intersecting circles, intersecting spheres. In case of intersecting spheres, the circle will be generated here. We take a point of intersection, some p lies between C1, C2 both spheres. I take two planes which are tangent planes to the spheres. Here L1 is the tangent plane to the sphere C1, L2 is the tangent plane to the sphere C2. So I am taking two tangent planes at the point of intersection to the given two spheres. So here I am measuring angle between two planes, we know that the angle between two planes, there is the formula cos theta equal to L1 L2 plus M1 M2 plus N1 N2, where L M N are DCs of the two planes. So instead of measuring angle between two spheres, I am measuring angle between two planes which are tangent planes to the given spheres at a point of contact, at a point of intersect P, at common point P, you can say common point P. So at the common point we are drawing two tangent planes and measuring the angle between them. Then the angle between the two tangents is said to be angle between the two given spheres. So this is the concept. Here we can see the formal definition. Angle of intersection of two spheres at a common point P is the angle between two tangent planes at that point. So we are taking some common point. Here common point lies C1 C2. Here some circle is generated, lies on the circle also. So at the point P, I am taking two tangent planes to the both spheres and measuring the angle between the tangent planes. The angle is said to be the angle between the given spheres. Angle is equal to angle between the radii of the spheres, radius of the sphere to the common point, the radii between perpendicular to the respective planes at the point. Here is the concept. If we take radius of two spheres through P, we are measuring radius, the line segment of radius from the P lies on the two spheres. We are measuring radius R1 R2 through P, then the angle between the two line segments or lines R1 R2 is equal to also the angle between two spheres. That so in some other way we can find the angle between this radius. So in both way the angle is the same. So here is the problem. Before going to problem, so here is the formula to find. Here is the formula for calculating angle between two spheres. Cos inverse equal to R1 square plus R2 square minus d square, not whole square, this is only d square by 2 R1 R2. Or we can write, if the angle between two spheres, then cos theta equal to R1 square plus R2 square minus d square by 2 R1 R2. Here is d is the distance between two centers C1 C2 and R1 R2 are the radius. If the angle is 90 degrees, right angle triangle, then cos 90 equal to 0. So this is cos theta equal to R1 square plus R2 square minus d square by 2 R1 R square. The portion is equal to 0. Then the numerator equal to 0, R1 square plus R2 square minus d square equal to 0. Then R1 square plus R2 square equal to d square. This is the formula used for used in the case of spheres intersecting at right angle. If we take r1 r2 d square, the actual values, that is r1 is the taking the radius of first sphere, and that is u1 square plus v1 square plus w1 square minus d1 square. Similarly, r2 equal to u2 square plus v2 square minus w square w2 square minus d square. Then substituting in the equation, similarly d equal to the center distance between two centers c1 c2. After simplification we get a result, an interesting result, that is 2u1 u2 plus 2v1 v2 2 w1 w2 equal d1 plus d2. Here is the some derivation. Actually this is called a condition for two spheres x1 x square plus y square plus z square, 2u1x plus 2v1y plus 2w1z plus d1, and x2 is x2 x square plus y square plus z square plus 2u2x plus 2v2y plus 2w2 plus d2 equal to 0 to be orthogonal, or they are intersecting at right angle. So we can say orthogonal is 2u1 u2 plus 2v1 v2 plus 2w1 w2 equal to d1 plus d2. Here is a small derivation. This is a very simple one. So I am taking the center of first sphere, that is minus u1 v1 w1, second sphere minus u2 v2 w2, and r1 square r1 equal to and r2 equal to taken as a formula, and c1 c2 distance between c1 c2. Here I used x1 minus under root x1 minus x2 whole square, y1 minus y2 plus z1 minus z2 whole square. Here two spheres are later, the two spheres are orthogonal. Then from previous result, here r1 square plus r2 square equal to d square, or we can write c1 c2 whole square. Using the result, so c1 c2 whole square equal to r1 square plus r2 square. Here c1 c2 whole square, c1 c2 is this, removing square, this part is taken, and r square, removing the squares of r1 r2. So here a minus b whole square, a minus b, a minus b. So I am expanding the formula a minus b whole square 3 times. I get the similar point, similar values to the both side of the equation. After cancelling u2 u1 square, u2 square, v1 v2 square, w and w square, these 6 terms left and right, we get the remaining part is 2 u1 u2 2 plus 2 v1 v2 plus 2 w and w2 equal to d1 plus d2, which is the standard result used in case of if two spheres intersects orthogonally or at right angle. Okay, thank you.